So the initial name was literally not CUDA. If you browse far enough in the source code history, you can see it was called not CUDA. The name ZLUDA was invented literally the day before first public release on GitHub.
Welcome to the Beyond CUDA podcast. I'm your host, Jeff Tatarchuk, co-founder of TensorWave, the AMD GPU cloud. Today's guest, we have Andrzej Janik, the developer behind ZLUDA, a tool that lets CUDA run on apps on AMD and Intel and GPUs without any code changes at all. Initially was developed at Intel and later funded by AMD. And there's a lot of mystery around the story of exactly what went down there. But we're excited about diving in to learn more about you, Andrzej, your background, and the whole ZLUDA journey and how we got to where we're at today. Thank you for being on the show.
Thank you for having me. It's a pleasure.
Awesome. Well, let's start off at the very beginning, man. How did you get into software development and where did the whole journey begin?
When I went to university for a computer science degree, so I'm not a child programming prodigy. So I decided to go for a computer science degree because I realized that, hey, I'm good at math. Computers are being more and more important, and they're going to be more and more important in the future. So I just used the full power of my ignorance and went for a computer science degree, and that's why I learned how to program. So I had a pretty normal computer science course. I learned to program C, then Ruby, Java, C#, C++.
And as you were working on your computer science degree, where did you see, or what interested you the most in the midst of all of that?
Initially, I was mainly interested in desktop programming, in graphic user interfaces. So I spent a lot of time learning how to program WPF, which is, and some WinForms, which are the leading user interface libraries on Windows on C#. But with web development being more and more important and desktop programming being less and less important, I've been going with my programming skills lower and lower in the stack. So I started as a C# programmer, then worked as an F#, and this was purely backend, no user interface. Then when I worked more in the, say, funny position at Intel, working in assembly actually, and then GPU programming.
Yeah, that's what I was going to ask next is what drew you into GPU software engineering, and tell us a little bit about your experience at Intel.
So this was a pure accident. So I joined Intel to work on the compilers in their CPU compiler team. They had an interesting position in sort of quality assurance, where you had people double checking the output of the compiler, so the quality of the assembly generated. So we had a certain degree of automated performance profiling of the workloads we cared about. So we knew if there was a regression coming from the compiler when it comes to runtime of the benchmark. So a benchmark was usually most of the time it was the industry standard spec benchmark, which is usually used to benchmark GPUs. So we would get a performance result and would know it is a regression. And usually the regressions in the compiler would be very small, like 1%, 2%, 0.5%. From this, we'd have people, including me, take a look at this regression to understand if it's actual regression or just a fluctuation. And for this, we'd use performance profiling tools, and we'd work with the assembly. So we'd use GDB to check some things. We'd use LinuxPerf, we'd use vTune, try to prove what happened and approximately why it happened. So usually there were two leading cases of performance changes. One was the sections of the code in the file were rearranged, and this led to weird cache effects, which were not regression, they're just random effect. And the other was the changes to the vectorizer. Some blocks of code were vectorized or were not vectorized or were vectorized in a worse way. And those were actually reportable. So I worked on this for, I don't remember, a year or two at Intel. So I was responsible for the quality assurance of the new backend, because at the time, the Intel CPU compiler was moving from their own bespoke backend to backend based on LLVM. So I was responsible for quality checking this new backend. So I was heavily working on the compiler. And then one day, my manager came in and told us all, because there's more of us, guys, starting today, you're not compiler developers, engineers, you're GPU programmers. Start running GPUs. Because this was like 2019, I think. So Intel at the time realized we want to release those GPUs, or maybe 2018, doesn't matter. We want to have those GPUs, but we don't have enough GPU programmers. So let's ask some people to learn GPU programming. And then for a few years, I was working on GPU optimization. So optimize GPU code mainly. So I was a developer, then a manager of a team. We were working on optimizing workloads that were important for MLPerf mainly, because we were working on pre-silicon GPUs, not yet released GPUs. So we're trying to optimize the workloads from MLPerf to the maximum of our ability, and then work with the hardware architects who could take this feedback and change the hardware, improve it or make it worse, see what is the effect. As I was working on those problems, and I said I became a manager, I was not really doing much of programming, and I felt I started to miss it. And so this is one thing. Another thing is, it was the start of 2020. We're all spending a lot of time or houses or apartments. And the third thing was, at the time, Intel GPU division was moving from writing host code in OpenCL to writing host code in level 0, which is different API, which gives you more control of Intel GPU. I was keenly interested in this new API. I was pushing my team to adopt this new API as quickly as possible, but I had relatively little experience with it. So I saw some samples of it and I liked the overall shape, but I wanted to learn more about this API. So with this all newfound free time and curiosity about this API, I thought, what sort of project I can do to really exercise this API? I thought, well, I was slightly curious about NVIDIA GPUs because I had no experience programming the NVIDIA GPUs. So my GPU programming career was on Intel GPUs. So I decided, let's try implementing CUDA on Intel GPUs with level 0, with all my skills and knowledge. I didn't plan for this to work. My assumption at the time was that I'm going to run into some sort of roadblock. Either maybe it's not going to work at all, or the performance is going to be terrible. But after a year of work, it turns out it can be done. Can implement, to a large degree, CUDA enough to run actually a closed source commercial application on non-Nvidia GPU.
Yeah. When was the exact moment when you realized that running CUDA somewhere else other than NVIDIA was technically viable? Do you remember that moment, or is it an evolving moment?
Yes. So this was late 2020. Running the first Hello World application, we just added 2 numbers. I remember this green text because green test passed, and it was, wow, it can actually work.
Amazing. Quite a bit of time. Was it like 4 or 5 years at Intel working on this, developing it? And then you were recruited over to AMD.
Yeah, so this was not end of the Intel history. So
Oh, please keep going.
because I reached my Hello World application. It worked, but I don't remember, 1 or 2 months I got Geekbench to work, which is a commercial closed-source application, more complex, and it worked with relatively good performance. I don't remember, I think it was actually on par with original OpenCL backend. Anyway, I released it. So I thought it's a fairly small project, not going to be interesting, maybe for a handful of people. I released it on GitHub and I emailed guys at Phoronix because Phoronix is, I think, the only website which really cares about such open source, GPU related, low level stuff. So I let Phoronix know. I was happy with myself. I thought it's a big step, but I should continue working on this, and maybe I have some more interesting applications. Then it's going to be more maybe, because I didn't tell anyone at Intel that I'm working on this. maybe in a half a year or a year, when I get something more impressive going on with some of Intel, we will realize it would be very funny. And I laugh at it. 2 days later, I log onto my work laptop. It's 8 a.m. and the first thing I receive, first message, is from my manager, a message, Andrzej, we need to talk. And this is not how you want to start your day. So turns out that people at the GPU division realized the very next day. So the news spread very quickly. And he was just trying to confirm that I did not use that I'm basically not leading a renegade team inside Intel, which is working on this project. He worked with me, so he knew what I was doing, but this question came from another division, from a manager two layers above, so he had to double check.
Wow.
It was fine. It was fine after confirmed that no, I'm not leading a renegade team inside Intel. And Intel was briefly interested in supporting this, but they decided not to. And then I joined AMD.
Now, did you originally call it ZLUDA? Was the side working on the side?
Yes and no. Yeah, I remember. So the initial name was literally not CUDA. Okay, if you browse far enough in the source code history, you can see it was called not CUDA. The name ZLUDA was invented literally the day before first public release on GitHub.
I got it.
And I live with the consequences of this ever since.
It's a great name. It's definitely memorable. So you're working on this at Intel on the side. And what was the pull from Intel to AMD? Did AMD discover what you were working on and specifically recruit you because of ZLUDA?
Shout out to Cedric, who was a manager at AMD. And so what he was responsible at the time was professional creator workstation workload. So things like Blender, Maya, 3ds Max, this sort of thing. Photogrammetry, like reality capture. The problem is, for a lot of those applications, there's GPU support, but it is CUDA only, and those applications are closed source, and those applications you just pay a license, right? There's some degree, there are some open source alternatives, but they're usually not used by professional creators. Well, the open source alternatives are making improvements, but are not the same. Blender is getting more and more popular, but as I understand, the industry standard is still Arnold. So if you don't have Arnold, you don't have reality capture, you don't have 3, 4, 5 other applications, then professional creators are not going to buy your GPUs. And those professional creators are, as I understand, they're interested in powerful, top-of-the-line GPUs, because if you're doing rendering, then the time is money, literally. So you want to have a powerful GPU, and have all your applications work with this powerful GPU. So what he needed was, in this market, he needed CUDA. He needed a CUDA on AMD GPUs. And when he learned about ZLUDA, he had an idea. This is an Intel GPU, but maybe, just maybe, it can work on AMD GPU. So we had a relatively long and in-depth discussion about what ZLUDA can do, which is something. It can do Geekbench at the time, and the things it cannot do, which is mainly a huge unknown area. And he offered me that AMD is going to fund this work, but he understands that this is very speculative, because we didn't know if it's going to work on AMD GPUs as well as on Intel GPUs, so maybe it will work worse. And we don't know if it's going to work on those complicated applications. And the complicated application at the time was something like reality capture, Blender. But it wasn't super important because it was open source, but still interesting point. But he decided, okay, it's worth a try. So I started working on porting the ZLUDA to AMD, removed the Intel GPU backend, added AMD GPU backend, and relatively quickly enabled 2 applications, which was, I think, reality capture, 3D FZFU. So there are applications where you have a 3D object, you take photos, and from these photos, the application can reconstruct a 3D model. And they were well, there was a lot of effort to make them work, but they were not like the top of the complexity, as I will learn later. Minor spoiler. Also, it went relatively well, and I think Cedric planned this from the day zero. And he told me, well, it goes so well, let's change our class. Let's try something more challenging. And something slightly more challenging was Arnold. And Arnold is extremely complex application. I didn't realize it at the time. So what Arnold does, it's a renderer, and it uses NVIDIA Optics, which is a library for ray tracing. And this was a lot of work. I don't remember how long did I spend. I think half a year or more, because it's hugely complex, and I had to recreate the optics, which is, again, sort of complex ray tracing framework. It uses its own dialect of PTX language. It uses its own host code. It has certain functions for things like building bounding boxes for the models. I used the HipRT library for a lot of stuff. It was still a lot of work just to get this ray tracing done. And in the end, I managed to get relatively non-trivial Arnold scene rendered. I think it was by far the most complex application that ZLUDA enabled Arnold. So it wasn't perfect. Some pixels were slightly off, had slightly wrong color. Some lighting was also slightly wrong, but it worked.
Yeah.
Mostly. So, and this was the high point of ZLUDA at AMD. Unfortunately, there are some changes inside AMD, and AMD decided that this is more of a, as I understand, it's more of a strategic threat than a strategic asset. Decided not to fund.
Why did they see it as was it new management shifted and they saw it, or changes in the software architecture direction and they saw it as a strategic threat? What was the pushback?
So I don't have good inside information. All the information I have is second hand and third hand. Interesting facts. So I used to live in Gdańsk. Intel has a relatively large office, but also AMD has slightly smaller office, and information travels. From what I understand, AMD sort of changed their mind, decided, okay, this is a threat. We shouldn't sponsor it.
But a threat to what? Was it a threat to ROCm? Was it because I mean, AMD's built on an open source platform. You think they like, where did you, or if you have any inclination on where you think that threat was coming from?
The contract elapsed and I released the source code, because my understanding at the time was that AMD is just not interested in pursuing it further. They're confident in their ROCm platform, and they do not need it. And when I was joining AMD, so we didn't know if it's going to work. So we expected that it's either going to work or it's not going to work. If it's not going to work, then I can release the open source. If it's going to work, then obviously AMD is going to fund it. So since AMD decided not to fund it, I released the open source. And sometime later, AMD lawyers started sending me legal threats, basically telling me I have to take everything down or there will be consequences. Very dire consequences. So I rolled back this code. And going back to AMD, so I literally asked AMD lawyers what sort of reasoning they operate on. And they gave me nothing. They just told me, tell community that AMD requested to roll it back because they claim this is their intellectual property, which should not have been released. So I never got a clear answer from AMD, but second-hand, third-hand information I have is their thinking is that if a user uses ZLUDA to run an application he could not run before, great for the user, but horrible for AMD. So those happy users will not pressure the developers to natively port their software to AMD platform. And in this way, you have rely on the platform of your competitor, on NVIDIA's CUDA. So this is, I think, their present thinking.
Interesting. And so you released it publicly, open source, AMD's down. And it seems like it survived 3 lives, first at Intel, then through AMD, and then where it's at today. Talk to us about where things have evolved. I know we spoke about a year ago, and I know I saw some news back in October that it was anonymously funded again, and I'd love to hear where things are at, and if you can share anything about the roadmap and where things are going with ZLUDA.
Yes, so right now it's funding is progressing at relatively healthy pace. So now we are focusing on machine learning workloads, and we are focusing on desktop GPUs. Though, if someone is listening and have an inclination to take the project in a slightly different direction, then you are very much welcome. I would love to see this project supporting Blender or supporting non-desktop GPUs or even non-AMD GPUs. If you want to contribute, please come. You're welcome. I will help you. The focus is machine learning workloads on AMD desktop GPUs. And so the goal this year is to run relatively complex machine learning frameworks like PyTorch or JAX on ZLUDA. It's not going to, not everything will work out of the box, and PyTorch is not, just having PyTorch is not enough because we have people building on top of PyTorch. So there will be more and more work next year to improve our compatibility with our performance with PyTorch, JAX, TensorFlow. There will be probably more frameworks, more machine learning workloads. It's an evolving field. And then there's many different directions I would like to take this project. So I definitely always want to have more compatibility, more performance.
I wanted to hear, what are the things that you're currently most excited about? What comes with ZLUDA?
I'm currently excited only about the things that are exciting for me and nobody else, which is I can go back and do certain things properly, which were done, well, somewhat badly in the previous version of ZLUDA. So previously, ZLUDA was in sort of proof of concept. So I get a lot of corners to move as quickly as possible. This time we can do things correctly. A lot of things are very minor, very subtle, things like correct handling of floating point rounding, holding point denormals, making sure the performance libraries are mapped more correctly. So this is exciting to me, probably not to the users who are waiting for those workloads to be enabled, but they will be enabled, they will work better.
Yeah. And where do you see the biggest opportunities? Obviously, there's a lot of people trying to work to build things outside of the CUDA ecosystem. It's been shown that there's a lot of bugs that exist. Where do you see the opportunities that exist?
So I can only speak about ZLUDA, and from the ZLUDA perspective, what I want to see. So it doesn't look like AMD is improving their libraries at the pace I'd like to see. So things like the ROCm runtime and performance libraries, I would love to see someone maybe step in and work on those libraries, even outside of AMD, maybe even just for ZLUDA. So I would like to see a better BLAST library, a better DNN library that covers the parts of the API of QDN API that are just not covered by AMD. I would like to see maybe more robust runtime that handles things like textures better. This is areas where I would like to maybe move in with ZLUDA, but not this year, unless someone comes and volunteers.
Yeah, that makes sense.
But I think, you can build something better, faster, more compatible.
I know that's the experience when we talk with developers. They're excited about optionality. They want to see things that exist outside of the NVIDIA ecosystem. We talk to a lot of vendors. They want multi-vendor GPU optionality. But when it comes to the developer experience, there's a lot of hesitation around making that as easy as possible to be able to do. What do you think needs to happen on the ZLUDA side to make that doable?
Maybe
other than a couple $1 billion and a bunch of developers to actually rewrite and develop the whole stack all over again.
Yeah. So first thing, if you're talking about going beyond CUDA, I'm probably not the best person because I'm My project is keeping all those applications in CUDA, just having CUDA on different hardware. But if you were to ask me if I had billions of dollars to develop this project, then I would spend them not only on ZLUDA itself, but also on the libraries, because libraries are lacking. So if you look at the very important library, CUDNN, right? So this is, if you look at each and every machine learning framework, PyTorch, TensorFlow, doesn't matter. If it runs on NVIDIA GPU, it uses CUDNN. And CUDNN introduced a new API, I don't remember, 4 or 5 years ago, and AMD equivalent library called MIOpen still has not implemented this API. And this API is relatively complex. It gives you a lot of space to improve performance. So I would like to have this API to have better compatibility with TensorFlow, better compatibility with PyTorch, because as things are right now, we have to ask PyTorch to use older API, which is possibly less performant. We have to ask TensorFlow to use older API, which again, possibly less performant.
That makes sense. I'm sure it's been an exciting journey from the beginning of ZLUDA to today. Is it still your primary focus?
Yes. So yeah, definitely. I spent most of my work time I spent on ZLUDA.
So what's next? What can we look forward to coming up with ZLUDA? Wrapping up here, what do you need help with as you're building an ecosystem? Where can people find you? Yeah, tell us about where things are at now.
Nice Discord server where you can find me. You can find some ZLUDA enthusiasts. Feel free to join, drop in, say hi. I think this is the biggest hub of ZLUDA activity. You can obviously find us on project on GitHub. Feel free to email me. My email is my GitHub profile. And there's a lot of remains to be done. Even for something like PyTorch or TensorFlow, you can see we have things open. Something slightly more exciting. So I'm convinced right now that it is possible to. You might have seen news recently that NVIDIA dropped support for, not sure if I'm pronouncing it correctly, PhysX, their library for particle effects on 32-bit games. So there's a lot of games that suddenly lost their particle effects or have those particle effects run very slow. I'm convinced that this can be brought back using ZLUDA. So if you want to be the hero of, retro gaming, then please come in. There's path for it, but I'm not going to work on this myself because I have slightly different priorities. But yeah.
I like it. Well, Andrzej, man, thank you for sharing the story behind this. I know it's been an important part in this journey of AI becoming multi-vendor and being able to build outside of one specific vendor for a while. And so thanks for coming on and sharing your story. And if anybody wants to continue to get involved in ZLUDA, he shared where to go. Thank you so much for your time, Andrzej.
Yeah, and thanks for having me. And as I said, feel free to contact me. You can find me on Discord. You can find me on LinkedIn. You can email me if you're interested in GPU programming. Then
awesome. Thank you, Andrzej.